I have learned a lot since I started going down this rabbit hole of solar power, battery inverters, chargers, etc. All began with the Sun Gold Power 6,000 watt inverter slash battery charger. What's up YouTube, Jason here with Byte My Bits, and in today's video I want to talk about my very first solar project. That's right, this is the first one, and I found out it is too big for me. What I mean by that is I am severely ill-equipped to give this inverter slash charger an actual real stress test. So that's one of two disclaimers today. One, I don't have enough batteries to actually test this thing to its fullest capacity. And two, Sun Gold did send this inverter over to me for free as a review unit. That, however, has absolutely no effect on the positive and or negative things I might have to say about it. With all that out of the way, the Sun Gold 6,000 watt pure sine wave inverter slash charger. This thing is a split phase output, meaning that you get 120/240 volts. Now it is a 6,000 watt unit, and each one of those split phases put out 3,000 watts each. So if you are building a system and you want to wire things up, you got to kind of balance the books a little bit there. Sun Gold Power does offer these models in 12, 24, and 48 volt versions, and for today's review, I have the 24 volt version. It also uses a split phase 240 volt charging requirement, so as you might have seen on my channel, you might have to run a new line in order to hook this thing up to your house if you want to run off grid power. It does, however, have a low frequency inverter. And if you don't know the difference between a low frequency inverter and a high frequency inverter, the key differences here is that the low frequency inverter is going to be able to handle higher output, but just kind of temporarily. Basically, surge power is where the low frequency inverters really hit hard. And also because it has such a huge iron core, it runs cooler, which means it's more reliable. So having a lower frequency inverter is a good thing. Although that means that this thing is 103 pounds or something. Like, it's huge, and it's even bigger when you want to lift it up yourself, hold it up against the wall, and screw it into the wall. Yes, I did that. Don't want to do that again. So with the pure sine wave lower frequency inverter, it does take about 77 watts just to idle. That means that if it's on, it's just going to be consuming about 77 watts, just kind of no matter what. There is a power save option on this unit, which means it'll actually kind of send a little signal out, say, hey, do you need me? No. Hey, do you need me? No. Hey, do you need me? No. And when it detects something, then it will turn on and go full send. With that going, you're looking at just about 22 watts idle. Some of the key features here, and one of the really necessary features here, is the remote battery temperature sensor option that comes built in, which means if it detects that the batteries are running too hot, it will stop charging it. I know that's kind of an obvious statement, but hey, it's really helpful if you want to keep stuff from burning. It also features a port to start a generator automatically. And if you were to actually tie this into your power grid goes down, battery dies, and then you want to turn on your generator, I definitely would recommend hooking up an automatic transfer switch that would move power to the generator so it's not going to go into the... You guys understand that. That's not what this video is about. The key is it has the option to automatically start a generator if your generator has a 240 out and the ability to be remote started. And that is kind of sort of what I want to roll into, like maybe the first thing that I personally, as a preference, don't like, and that is you absolutely need 240 volts in order to charge this thing. So for example, I have a generator out in my garage. It's a very tiny generator, like not enough to do a whole lot. So of course, this really, really tiny generator only has 120 volts out. So if I was going to try to plug it into this, there's literally no way to charge this thing. I need 240 volts minimum in order to charge the batteries through this battery charger. That also means that if things are hitting the fan and I don't have any power and I want to use all the extra batteries that I have laying around the house that have, you know, the 110 outlets, and I want to drain all those just to power the battery to power the house and all that other stuff, I can't plug anything else in. There's no 120 or 110 support to charge or to use the charger built into this inverter. So that is more of a preference. And really what that means for me is that if I do want to rely on a generator for some kind of crazy thing where I'm gonna need, that kind of power, that I would have to make sure that whatever I get into has a split phase 240 volt setup. But going back to the whole low frequency inverter thing, this thing claims to be able to handle up to 18,000 watts peak power for 20 seconds. I have absolutely no way, no way to verify this. To give you the rundown, in order to get this initial system set up, I bought 2 batteries. They are 100 amp hour 12 volt batteries wired to 24, so it's only 100 amp hours, and they have a max current draw of 100 amps. So if you do the math, that's 2,600 watts total that I could bring or pull out of those batteries at any given time. So while I have went on this entire adventure of getting, the sub panel wired and testing out, hooking this thing up to my entire house to run the house, etc., it's really come down to this. I cannot draw enough power because I don't have an adequate supply of batteries. The batteries that I have, realistically, I should only expect 2,400 watts out of. I've gotten 2,600 watts out of them, but not for very long. I mean, usually just only when it's topped off and, you're not pulling that much too long. So if you are looking to get into something like this, just bear in mind, you do need the batteries to back it up. You have to have some big beefy battery banks if you actually want to use the 6,000 watts that this thing offers, or the potential 18,000 watts it claims it can do for 20 seconds. Now I know 18,000 watts seems a little crazy, but if something kicks on like an AC compressor, dryer unit, something like that, and that initial startup, peaks it out to 15,000 watts, but it's only for 5 or 6 seconds, then hey, that's where something like this comes into play. If your batteries, however, cannot handle that, then you're just kind of screwed. Onto the unit itself, on one side you have where you wire all of the AC stuff. That's alternating current, of course. That's where the 240 in and the 2 different phases that come out that you want to wire. Now, I would highly recommend, depending on your setup, probably hooking this up to a sub panel. That way you can balance things out accordingly, things like that. What I did was literally just run it to 2 separate plugs, and then I have it hooked up to my rack. The initial idea behind all of this was like, I'm not gonna try to run my house, but I'm gonna try to power up my rack. So if the power goes out, the battery can kick in, it can power my rack for, I don't know, however long it can power it for, depending on however many batteries I got. But then I ended up buying these 2 batteries and finding out that my rack, which also powers my main computer, my Plex server, and all my network gear, etc., just does not have the ability to handle this thing. Like, as long as I'm not mining cryptocurrency and doing that extra draw in my computer rack, then yeah, I can be within the spec in order to have the inverter handle the rack for probably, 45 minutes. But anything past that, the server rack that powers my main computer, monitors, etc., can actually overload the batteries that I have connected to this inverter. It's kind of sad. So instead, what I've been doing is mining on a laptop that draws about 260 watts and can last for about 5 hours, give or take, on the batteries. And in an upcoming video, you will see a review on a couple solar panels that was sent to me that I have set up for testing purposes to charge those batteries as much as they can during the day. And then with this inverter, you have the ability to designate whether or not you want it to prioritize battery power or grid power. So what I have it set up for is battery prioritization, which means it will continue to drain the battery until the voltage drops a little too low. Which, by the way, these are little switches that you can change on the inverter itself. It's on the other side. You have multiple options here. You can go 50, 60 hertz. You can do battery priority. You can do the AC input voltage range. You can even change the threshold. Like if you want to lower the threshold for how much voltage is available to trip the low voltage protection, you can change that as well. I have mine set to battery priority. That way, at least during the day, it will use the battery. And I have set up a separate MPPT charger with solar panels to charge that battery during the day. So hypothetically, best case scenario, the setup that I have right now, I can run for, I don't know, maybe 10, 13, 14 hours, give or take some change, solely off of the sun by mining with my laptop. It's not a lot, but because I really getting new batteries or getting more batteries is just not in the cards for me right now, this is what I have to make do with. Going back to the other side of the SunGold 6,000 watt inverter / charger, like I said, you have those dip switches, you have that generator automatic start. You also have the 2 main lugs to hook up your positive and your negative to your batteries. And you have the option to hook in a remote for the controls for turning the inverter on and off. This is a very simple switch. It uses a Cat5 cable, and it's literally like you have to turn it, the main switch off on the unit itself. You plug this in, you can route this, let's say inside if you have your power shed or something like that outside, and you can power cycle the device. So if something errors out and you need to turn it off, need to turn it back on again, you can do that with the remote. On the top of the unit is where you get all of the information. And this kind of rolls into another preference of mine. You do actually get like a little LCD display that rotates and it shows, your battery voltage, your load output, stuff like that. However, I kind of wish it would show me more. Like there's been a few different occasions where the thing faulted and it turned off, it started beeping and doing things, and I had absolutely no idea why. Like you have to go to the manual and it says, okay, this long of a beep followed by this beep and this beep, this means this, and you're trying to track it down. At the end, it all really came back to my batteries, where I realized that I am just completely underpowered for amp draw on my batteries. So that was all my fault, but it would have been a lot better if I didn't have to look at a manual and figure out what blinking lights and beeping noises meant in order to track down what the problem was and why it was shutting off. I mean, it has an LCD display there, so I just really kind of wish that LCD display would give me a little bit more information. Also, now that I've gotten into this, I've been dabbling a little bit in Victron stuff for the controller, for the solar controller. And holy bananas, that thing is just connected with Bluetooth. You can hook up a Raspberry Pi to it. You can do all kinds of things to see information, to manage that remotely. Whereas with the SunGold Power, you pretty much have that one little remote control to turn it on or off, or power save, or just on or whatever. And that's it. You have really no remote management capabilities whatsoever. I have to rely on a battery shunt to tell me what kind of power is being drawn or given to the batteries. So it's kind of inaccurate in terms of if I wanted to know just exactly how much I was pulling with the inverter itself, not counting the solar portion of it. So that's really where I wish that a device like this, a unit that can charge, invert, and it's huge, it can handle tons of power, and honestly, I'm really impressed by it. I'm really kind of surprised it doesn't have any sort of data connection available to it at all. I mean, yes, it is big, it is beefy, and it has options for 9 different types of batteries, which that's probably all or most of the battery options out there. I am currently running lithium iron phosphate batteries. That's just what I have, but you can run all sorts of different types of batteries. And the little LEDs on the front do a pretty good job at telling you what's going on with the device as far as status. Like it's floating, it's charging, it's inverters, line mode. The display does give you a little bit of information. One of the good things that I do like about this is that if you do want to run grid power, and you only want to use this as a backup solution, you could do that. If you want to set this up to prioritize grid power over battery power, it will actually bypass the batteries, use the 240 volt in, and go directly to the AC out. So assuming you had enough battery power to back things up that you wanted to run off of it, you could, like I have mine set up right now, but I need more batteries before I can actually implement it. You could have line mode bypassing the batteries, running your equipment, and when the power goes down, it will switch over and power that equipment off of the batteries. This thing offers a lot of power, a ton of power. If you can get the batteries to back it up, this thing can power most of your house, and in an emergency situation, it could really go the distance. For example, and I know this is gonna throw some people off here, but I set up a switch to where the 240 line that I ran from my sub panel that feeds the inverter actually goes into a 3-pole switch, and it goes into the middle, and I switch it over to the left, it powers the inverter. If for whatever reason things go down and I need to power things on or do things, and it's like an emergency, like, hey, we're gonna be down for like hours or days or whatever. If I were to go through my house, balance things out, turn off things that don't need to be ran, computers, for example, I don't need massive computers and monitors running if I'm in like, hey, I need my garage door opening mode. I can flip that thing over. Yes, you would turn off the main line. Please don't comment that. But it will turn it off and then feed it back into my sub panel, which would of course feed into the house. I've tested this. It works. It's amazing. I hit about 2,800 watts and it powered off because limitation of batteries. But the point is, in an emergency situation where you want lights, you want garage door openers, maybe a heater running, things like that, and you reduce your household intake to the absolute bare minimum required to run Plex and survive, then the way I have it set up right now works. Down the line, now that I got this backbone built and I kind of have a much better understanding of what I'm doing, I can add batteries. Once I can afford them and build on that battery bank and add solar and basically all of that, I have this backbone built now and this knowledge built now where I can expand this, and this inverter / charger is going to give me the leg room to do it. So huge shout out to Sun Gold Power for sending this unit to me. I look forward to expanding on my battery bank, getting this thing up and running, and as weird as it sounds, if I have enough battery, maybe even having a slight emergency somewhere where power gets cut off for a couple days and I actually get to flip that switch and be like, yep, I got power. Well, guys, if you have any questions, comments, concerns, or complaints, make sure to post those in the comments section down below. As always, thank you for watching, like and subscribe, and have yourself a great day.